Hello students, in the earlier classes we have solved some n jobs 2 machines problem, that is flow stops problems, using Johnson's rule. Now n jobs 3 machines problems also can be solved using Johnson's rule provided certain conditions are satisfied. Now let us assume a problem of 3 machines and 5 jobs. Here there are 3 machines are available for processing 5 jobs. Each job has got different processing time on each machine. For example, the job number 1 has got 8 units of processing time in machine 1, 5 units of processing time in machine 2, 4 units of processing time in machine 3. Similarly, 5 jobs processing time on different machines are given. Now what is the condition we have to find out? It means minimum of T1J. That means in the T1J, all the 5 jobs you have to find the minimum. That should be greater than or equal to maximum of T2J. That means the second machine, what is the processing time? In this processing time, what is maximum? Or either these conditions are the minimum of T3 should be greater than or equal to maximum of T2. That is, the maximum processing time of the middle machine should be greater than or equal to minimum processing time of the machine 1 as well as machine 3. Now, minimum of machine 1 processing time is 6. Among these, 6 is the minimum processing time. Minimum of processing time of machine 3 is 4. Maximum of the processing time of 2 is 6. In this middle machine processing time, the maximum number is 6. Now, as per these conditions, the first condition, 6 will be greater than or equal to 6. This condition is satisfied. 4 is greater than or equal to 6. This condition is not satisfied. If any one condition is satisfied, then this problem can be solved. So how we can find out the sequence? For predicting the sequence, we are going to find out some imaginary machines, G as well as H. The processing time of G will be equal to the processing time of M1 plus M2. Processing time of H will be equal to processing time of M2 plus M3. That means you add this processing time and put it as a G, and add these two processing time and put it as a H. In that case, these 2 or 3 machines can be converted into 2 machines, whereas the G and H machines are all imaginary machines only. There is no actual machines available. It is used for predicting only the sequence. Now, for the same jobs, I have just added 8 plus 5, 13, and 5 plus 4, 9. Similarly, we have found out the processing time of G as well as H for all the 5 jobs. Now, using this processing time, we can find the sequence using Johnson's rule. Among this processing time, the minimum processing time you have to identify, that is 8. So 8 is associated with your G. So here, near G, that is the first, we have decided to process the machine 3, job 3. Now we can strike off this, then among all other 3 machines, or other 4 machines, we can just strike off this. Now, there are 3 places 9 is appearing, the next lowest processing time. So, when the tie occurs, we can arbitrarily break the tie. All the sequences resulting out of this tie breaking will give a same value only. Now arbitrarily we can choose the 4 which is against your H, so the 4 can be processed at the last. Then we can strike off this 4. Then 9 is also having the lowest processing time 9. That means this first job can be processed just before 1. So this can also be strike out. Then next, the 5th job also can be processed just before 5. Only job left out is 2. So the 2 can be placed here. Now the resulting sequence out of Johnson's rule is 3, 2, 5, 1 and 4. Now for this sequence, we are going to find out your schedule. Now you can prepare the table like this for machine 1, machine 2, machine 3 and in time, out time for each machines. Now we fill up this job sequence as per the Johnson's rule. First third job, second job, third fifth job and first job and fourth job. So for the third job, just like with the process what I have explained in the n jobs 2 machines problem, we can start here processing time as 0 and then the third job has got a 6 hours of processing time. So 0 plus 6 is the 6 is out time for the job 3 in machine 1. Now it can enter to the machine M2 at 6 hours. There it is going to be processed for 2 hours. So 6 plus 2 will become 8. At 8th hour it is going to enter into the machine M3. There it is going to be processed for 8 hours. So 8 plus 8 is 16. Now this 6 hours after the machine 1 completes the third job, immediately we can feed with the second job. So second job can enter machine 1 at time 6 where it is going to be processed for 10 hours. So 6 plus 10 is 16. Whereas here at 16 hours only the second job is coming out of a machine M1, whereas the M2 completes the job by 8 hours and then it is being idle for 8 hours. It can take up this job only at 16 hours. So at 16 hours again the second job is having 6 hours of processing time. 16 plus 6 is 22 hours. Then at 22 hours only it can enter into the machine M3 and then 9 hours is going to be processed and it is 31. In the similar way, when you just proceed, this is the minimum max span time, that is 51 hours. Minimum max span time will be equal to 51. This will be minimum for this problem. When you just process these 5 jobs in this sequence, the time to complete all the jobs will be equal to 51. So this is how n jobs 3 machines problem can be solved into n jobs, converted into n jobs 2 machines problem, and then we can solve or find the minimum max span time. Now when this condition is not satisfied, then how to solve these problems? There are different methods available for such problems. One such method is branch and bound algorithm. So that I will explain in the next coming lecture. Thank you.